Okay, today we're going to start polymer matrix composites. What is polymer matrix composite and how we will actually focus on the manufacturing process of the polymer matrix composite. Since this course is about modern manufacturing processes, so we'll be concentrating on the manufacturing processes instead of other properties of polymer matrix composites or the testing methods or other things. So for this today's lecture, first polymer matrix composite. What is polymer matrix composite? First, you have to know that what is composite. Composite actually consists of two or more materials embedded together, but the properties of individual material will be retained at the same time. Because of the combination of different materials, we get a completely different property, which is better than the individual property of individual components. That's why we call it composites. Those are the materials. And another important thing about composite is that the individual components, they don't actually react with each other. Okay, they stay in the composite and retain their properties. But with the combination of them, when we use in the macro scale, with the combination of them produces much better mechanical or any other properties. So those are called composites, and it has a one of the component is called matrix. The matrix is the component where other elements are embedded. Okay, so if you talk about like solvent solution, solvent or solute, like for example, if you want to produce a solution of water with salt, then the water will be the matrix and the salt will be the reinforcing phase. Okay, in the case of more appropriate example for composite would be like cement. Okay? When we plaster the buildings with the cement mortar, we actually use cement as a matrix, and the sand or gravels or stones, whatever we use to enhance the property of the cement is called the reinforcement of the matrix. The matrix is cement. Matrix is the key component of a composite. Okay, so in this course we are going to actually study the polymer matrix composite. That means the matrix that we are talking about will be made of polymers. Okay? And there can be many other reinforcing phases. Okay, so the proper definition of polymer matrix composite is a composite material consisting of a polymer embedded with reinforcing phase, such as fibers, powders, sands, gravels, or any other things. Okay, whatever thing you want to incorporate into the matrix, you can incorporate, but the matrix will be polymer in this case. And in this case, for the polymer, we can use like thermoplastics or thermosets. Both of them can be used as matrix. And most of the cases that thermosetting plastic polymers are mostly used as matrix, and thermoplastics are also used. Thermosetting polymers that are mostly used are like phenolics, unsaturated polyester, and epoxies. I think you already know a lot about epoxy. Epoxy is the most widely used polymer, thermosetting polymer for producing polymer matrix composites. So these are the polyester, phenolics, or epoxy. Those are the matrix component of a composite. And for the phenolics are mostly used for in the case of particulate reinforcing phase, like talc powder or sand or any other nanoparticles. Those are used with along with phenolics to make a stronger phenolic compound or composite. And polyester and epoxies are mostly used with fiber reinforced plastics. Like if you want to use the fiber like jute fiber or glass fibers or aramide ceramic fibers, and there are also Kevlar fibers. Okay, so there are many other fibers can be used along with polyester and epoxy. They perform better in the case of um, polyester and epoxies. And for particulate phases, phenolics are best choice for producing polymer matrix composites. Here is a diagram how the polymer matrix composites are made. Those processes can be distinguished by two categories. First one is the process for continuous fiber polymer matrix composite. That means if you want to use the long fibers, like for example jute fibers, then these are the processes we use for manufacturing composites. And for short fibers, like it can be particulate type or particles, or it can be like chopped fibers. If you cut the long jute fibers into like 2-3 millimeter length, or less, or maybe 12 millimeter up to 12 millimeter, those are treated as short fiber. And if you want to produce composite using short fibers, then these are the processes. And first, for continuous fiber processes, open mold process, it is like you take a container and then you use the container to shape the fiber reinforced composite according to your requirement. There are two methods: hand layup or automatic tape laying method. Yeah, we'll be discussing those later on. And then closed mold processes, compression molding, resin transfer molding, um, and the filament winding. Like for example, if you have already seen that uh, nowadays the LPG cylinders, there are some composite LPG cylinders. Those are actually filament winding method used to manufacture those composite cylinders. And there's pultrusion method. Pultrusion method is basically for the production of beams of the long fibers. Okay, for long polymer matrix composites, we use pultrusion to combine a lot of fibers together to make beams or columns. And there are other methods like tube rolling. If you want to produce tube, then you can produce tube using the continuous fiber and the polymer matrix. And for in the case of short fibers, their open mold process, spray up method, closed mold process, compression, transfer, injection molding can also be used. And other include like centrifugal casting method can be incorporated to produce polymer matrix composite. And the last one is the continuous laminating composite, if you want to produce layer by layer. Okay. And for polymer matrix composites, reinforcement. For the reinforcement, you can use like fibers, particles, flex, and others. In any other materials, sometimes metals can also be used as reinforcing phase. There are some other elements like carbon, boron, etc. Okay, but the common fiber materials that are used is glass, carbon fiber, glass fiber, polymer Kevlars, etc. Nowadays, there are some natural fibers like jute fiber, aramide fiber, and then there is sisal fiber. There are many other natural fibers can be used, banana fibers, etc. And in some fabrication processes, the filaments are continuous, and in some cases, filaments are short fibers. Okay, those I have already talked about. In the continuous form, they can be like rovings or yarns. The rovings are the parallel fibers, untwisted. If the fibers are untwisted and a bunch of fiber like 1,000 fibers together, then we can call it roving, but they are actually lying parallelly. And in the case of yarn, it is like twisted collection of filaments. Fibers are twisted to produce a rope-like structure. Those are called yarn. Yarn is the most used term in the textile industry, where those individual fibers are spinned to produce yarn, and those yarns are used to manufacture the clothes. And continuous rovings are used in several polymer matrix composite processes, including filament winding and pultrusion. Pultrusion is the most widely used method for producing beams or uh, columns using rovings. Okay, and the fibers can also be prepared in the form of a mat, like we use jute fiber mats a lot. Like for example, in the packaging of rice, there are jute fiber sheets. Those sheets can also be used to manufacture polymer matrix composite. And the first type that we're going to study for manufacturing polymer matrix composite is molding compounds. There are various types of molding compounds. We're going to discuss that. First of all, what is the molding compounds for composite processing are mainly the thermosetting polymers are used in this case. And the curing of the composite is done during the shaping process or after final shaping. Once shaping is complete, then you cure the mold. And fiber-reinforced composite molding compounds consists of resin matrix with short randomly dispersed fibers. That means in this case, we're going to use the resins like thermosetting resins, for example, epoxy or thermosetting resin, and with the short fibers, like if you cut the jute fibers into pieces and then you use them as reinforcement, then that will be called short fibers are used for molding compounds. First one is the sheet molding compound. In this case, thermosetting polymer resin, filler, and fillers with additives and chopped glass fibers all rolled into a sheet. For producing sheet of thickness, typical thickness is like 6.5 millimeter. It's not a constant like for all the case sheet molding compounds should be of thickness 6.5. It's not like that. It's a kind of general sense. People make those 6.5 millimeter thickness sheets for a specific purpose. Then it can be varied. The most common resin is unsaturated polyester. Polyester is mostly used for making sheet molding compounds because it involves a lot of resin, and those polyester resins are kind of low cost, and they can be used here. And the fillers are usually can be talc, silica powder, limestone, glass fibers, and other natural fibers, but typically 12 to 75 millimeter long. The length is restricted in here because we are going to make randomly dispersed fiber reinforced composite. In this case, short fibers are like 12 to 75 millimeter long, and account for about 30% of the SMC by volume. If you consider a volume, the fiber actually holds 30% of the volume of the total composite. If there is a sheet of 10 millimeter thickness and 10 millimeter width, then 30% of that area will be incorporated by the reinforcing phase. That means either glass fiber or talc or silica powder, etc. This is the method how we produce the sheet molding compounds. In this case, the continuous rovings that are used. For the continuous rovings are chopped into pieces according to the desired length and spread in here in this place. And there is a continuous moving carrier film at the bottom and also at the top. That carrier film actually carries the material. Okay, and resin pastes are supplied from the bottom here and also from the top. Okay, the resin actually sticks to the carrier film and then it propagates in this way. And also the bottom resin, the bottom carrier film also carries the resin from another place where a doctor blade is used to maintain the thickness of the resin on the tape. Okay, that's same thing is happening on the in the top part in here. And chopped rovings are placed in between the two sheets, and then the rollers are used to compress to disperse the fibers into the mix the fibers into the resin paste, and then curing occurs in this region. Okay? After curing, then you take up in the take up spool. Okay. And for second one is the bulk molding compound. In this case, it is ingredients are similar to those sheet molding compounds, but the compounded polymer is in billet form rather than sheets. It's kind of a cylindrical form. Okay, the billet form is called cylindrical form. Cylindrical form composites are produced using the bulk molding compound method. In this case, the fibers are typically shorter because they need more flowability. If the fibers are longer, then fluidity is lost. Okay, and in this method, we need to use an extruder to get out the cylindrical form using the extrusion method, and that is why the fibers has to be smaller. In the previous one, we said like 12 to 75 millimeter long, but in this case, it has to be like 2 to 12 millimeter long to obtain greater fluidity to pass through the die of the extrusion method. And the billet diameter, the output diameter usually varies from 25 to 50 millimeter in diameter. Like you are going to produce a cylindrical shape with a diameter of 25 to 50 millimeter using the polyester resin with fibers. And the process for producing BMC is similar to that for SMC, except the extrusion is used to obtain the final billet form. Okay, the same thing is occurring. That means there will be the polymer phase, like this one. There will be the polymer phase, but finally, when you take it out, it's not in the sheet form. It will be like cylindrical or rectangular form, but with greater thickness. Okay. And BMC sometimes also called dough molding compound, DMC, because it looks like a dough, like, and that is why it is called dough molding compound. And because dough-like consistency, that means it has to be consistent. The fibers has to be distributed evenly in the polymer matrix. And some other compounding method also available, like thick molding compounds, similar to SMC, but thicker, up to 50 millimeter. Instead of sheet, we call it like thick molding compound, and it is a much thicker output will result. And pelletized molding compound, basically conventional type plastic molding compounds consisting of short fibers. Like if you put the fibers and the resins together and then heat it up to or melt it, mix it, and then put it in a container of the shape that you want to make, and then you allow time for curing, or you put it in the oven for curing. That is called the conventional molding method, and that is called pelletized molding compound. And this one is the important, the prepregs, the most widely used the polymer matrix composites. Mostly these prepregs are bought from some companies, and then you give them the proper shape. The prepregs are basically the partially cured thermosetting resins. Okay, the fibers are impregnated on that. That means the fiber matrix, everything is ready. You just shape it according to your requirement. Okay, for example, these sheets are available as continuous sheet, and then you want to make a ball, then you put it in the mold and shape it according to your requirement. Okay, uh, this is the prepregs. That means partially cured thermosetting resins with fiber. Everything is ready. You just cure it. The curing can be like during or after shaping, whatever, whichever is preferable. And these prepregs are available as I said, like tapes or sheets. Okay, cross plied. It can be like cross plied, or sometimes it can be of unidirectional. Like if you want to consider a sheet like this, if the fibers are oriented unidirectionally like this, then it's a unidirectional tape. And sometimes the fibers are oriented like crosswise at certain degree angle. In that case, you call it like cross ply. Okay, fibers can the cross ply is said like fiber orient. It depends on the fiber orientation. It can be unidirectional, or it can be cross ply sheet or fabrics. And prepregs are fabricated with either continuous filaments rather than chopped random fiber. Prepregs are mostly continuous filaments or mats, okay, instead of the random fibers, that means chopped fibers or small length fibers. And that is why the strength of these composites, which are made from prepregs, are with actually has greater strength than modulus. And advanced composites like reinforced with boron, carbon, graphite, Kevlar, as well as fiberglass, and all other natural fibers can also be incorporated to produce the prepreg, and then a prepreg is used to shape the final product. Okay, that's all for today, and we'll discuss about the open mold process in the next lecture. And if you have any question, please shoot.